So with some basic understanding on charges, we can move on to current, electrical current. So where have you come across the word current other than in physics? Social, English, right? So ocean currents, there are different ocean currents out there, is it not? So what does current mean in general? Flow. Now, electric has to do with charges, charge or charges. Current has to do with flow. So now can you define the word electrical current? Yes, it is nothing but flow of charges, that's all. So in physics, we don't define things this way. It has to be very specific. So now let's look into defining current from the point of view of physics, hardcore. So for that, we need to understand the factors. So I'll give you guys a small tip over here. See, from now onwards, if you want to learn something in physics, right, especially a new topic, try to understand what are the factors. Factors means what is it dependent on. You know, what are the fundamental things it depends on, right? So try to understand that. Then the concept becomes simpler, definition becomes simpler, formula becomes simpler, right? And the questions become much simpler. So this is how you go about understanding something. Okay, so let me make you guys understand this. I have a wire. This is your wire. Through the wire, I've cut across using a green slate, I guess, green paper, whatever it might be, but I'm slicing the wire. It's a very close up view of wire. Yes, if I go very far, it looks like a small section of a wire. So I have a very close up view. So it looks like a tube. So inside your wire, we have a lot of course, it's made up of atoms and things. So we also have something called as free electrons. Free electrons are easy to extract and all of that, and they move within the lattice of the wire and things like that. Okay, so they can move across around say lattice, internal, and all of this. So basically, you have electrons which can move around say within the boundary of the wire. So now this is within the wire. I'll ask you two, three simple questions. If I have say two charges, right, moving across this green slate. So we have 1, 2, 3, 4, 5, 6, 7, 8. That's case 1. Case 2, we have 3 charges in the same point of time, right, in a different wire. There are 3 charges that is moving across. Again, for the same time period. Which case has a better current? I mean, what do you think it has a better current? With more charges or less charges? With more charges, is it not? So can we tell charges is a factor? The number of charge that it flows in a wire, that is a factor, right? Okay, so one factor is charges. Second factor, say I have 3, let me carry 3 charges itself, and these 3 charges move across this green slate. In the first scenario, they'll just move across. How many of them will move across? 3 of them in matter of 1 second. In second case, this is case 2, same 3 charges moving across the green slate very slowly. So which has a better current? One with slow moving charges or fast moving charges? Which has some change, some factor of current over there. Like you can tell, okay, I have a better current and all that. I have more current. When can I tell that? When we have more charges moving across within less point of time, is it not? If there are same number of charges flowing across, but one is taking less time, obviously that is said to be a better current. So time is a factor. Okay, so these are the main 2 factors for current, that is charges, right? So there's not a single, it can be a single charge or n number of charges, and majority of the time in wires, not majority of the time, most of the 99% of the time when we talk of electrical current, it has to do with flow of electrons. So it is not anything else, it's mainly electrons. So we can talk about charges as number of electrons. Make sense? So let me present it this way. So instead of writing hashtag, which means number in math, before the word hashtag or hashtag was there. But yeah, this was used as number, to represent number, shorthand. So let me use alphabet N, and charge of one electron is fixed. It's as of now till date, the charge of an electron is fixed and it is represented by E. It has a specific value that you need to memorize, that we'll be talking about later. So can I tell charges as N into E? It's a better representation, and time is T. And now can we define current? Yes, we are almost there. Now we can define current. How? Simple. It's the amount of charges. Makes sense. We just saw that. Flowing through any cross section of a conductor. So obviously flowing, that's the word current over there, in unit time, the factor of time. So we have charges N into E, time factor T, and something called as cross section of a conductor, that you will understand in time. No hurries. So that will be understanding in resistance actually. So I won't discuss much over here. So point is, we have amount of charges with respect to time. So current is nothing but, can you guess? Is it charges, number of charges into time, or time divided by number of charges, or how is it? What do you think it is? Right? It is nothing but number of charge or charges divided by time. So in terms of variables, in place of current, I'll use the letter I. In place of number of charges, we understood this, that is, it is N into E. And in place of time, we will use the letter T. This is a formula for your current. So a bit more lazy formula is Q by T, where Q represent N into E. So you can remember Q as a bag of, not marbles, but bag of electrons. So this is a bag named Q. It has electrons in there. Not one electron, maybe one electron, but yes, it can have more than one electron, indicated by N, N number of electrons. And since each of them have a charge of E, so the total charge is N into E. Right? So we have the other formula is I is equal to Q by T, or Q is equal to I into T. These are the two formulas that we need to remember. Okay, so this is your definition, this is your formula. Right? Again, I'll repeat. We understood charges as a basic, fundamental part of matter. So we can't define it, but we can see the effect of it. Then we saw that if they start moving across, we are calling that as electrical current. So basically, it depends on the number of charges and the time it takes. Right? So we are defining current as amount of charges flowing through any cross section of a conductor in unit time. That's the basic definition. It sounds fancy, but you'll understand in time. So amount of charges you understand, divided by unit time. Unit time means, say, 1 second. Unit is 1. Unit time is 1 second basically. So the formula goes like this: current is equal to a bunch of charges and the time it took to cross. If you divide that, I'll get the current at that moment of time. Okay, for that flow, we'll get the current. So symbolically, I is equal to Q by T, where Q is N into E. Right? So these are your kind of 3 to 4 formulas that you're looking at the screen. So one of the best way to remember this is the first formula. Okay, not that. Actually, this is to remember the word queen. Right? Q is equal to E into N, or N into E. Again, it's my way of remembering it. I teach my student, and if you guys find it nice, then you can do the same. If not, you can remember the concept and remember the formula. The second way of remembering this is quit. I mean, the second formula, the second trick is quit. The word quit. Queen, quit. So Q is equal to I into T and Q is equal to E into N. Okay, so after this, we'll be understanding unit of current and to define 1A. What is this A? We'll be discussing in the next video.